This conference will now be
Yeah,
recorded.
the whole session will be recorded. So this is the course content. So everyone knows this, but let me explain again. So today first lecture will be about introduction of SAP HANA database, and then tomorrow will be a preparation of installation, and then we'll see the installation as well. Try to complete the installation by tomorrow. Then post installation, then admin tools for SAP HANA database and monitoring tools available. Then HANA operation, what operation we perform in the HANA database, we'll see in detail. Then memory management and the data persistence. Then technical deployment options. Okay, so till here technical deployment option we will able to complete the 50% course. And then after that backup and recovery. Then user management in HANA DB. Then multi-data containers, we'll see in detail. Then HANA scalability concept. Then HA and DR supported for the HANA database. What are the options available for HA or DR in HANA systems? We'll discuss. We'll discuss more HANA system replication, and then HANA Cockpit 2.0. We'll see how to install, how to configure, how to monitor the remote desktop, database to the cockpit, and then we'll see the HANA DMO migrations from any database to HANA database. So this will be a complete course content for the HANA DB. Okay, so let's start with the introduction. So yeah, so in between I will, I'll also give you the interview questions, so you have to just note down. During the session I'll give you the interview question as well. So let's start with the HANA introduction. So what is SAP HANA? SAP HANA stands for high performance analytic appliance. What do you mean by this sentence? So high performance means it's provide you the speed. Analytic means it's provide you real time data for reporting, and appliance is nothing but it is just it's a combination of hardware and the software. So appliance means it contains hardware part and the software part as well. So software is totally towards the HANA database, and the hardware side, if you see that we require the, the CPU and the huge amount of CPU and memory, because HANA is in memory database and the memory requirement is very huge. To perform the parallel processing, we require a huge number of CPU. So if you have the number of CPU, then you can have the, multiple parallel processing, multiple process you can run in the HANA database. So appliance is nothing but a combination of hardware and the software. Software side I will discuss later. Okay, maybe in next slide, maybe, yeah, coming slide. So HANA is basically a real-time database. So basically HANA database is used for real-time reporting. Okay, like for example, real-time reporting means what? Real-time data. Okay, so HANA is basically used to provide you the real-time data. So whenever the user enter any transaction in the HANA database, that data is available for reporting. So so functional BW consultant, then they can build a reports, okay, on that data, and that data is available. So no need to load the data. You don't need to load the data like in the BW systems. Load the data, full loading, and then full you perform BW team perform the full load and then delta load. So that is not a real time data in the BW system. That is the batch driven. Whenever you load, the data will come from ECC to the BW system, and then you report that data. So that is not a real time data. But in HANA, if you are using the application, hey, what is the issue, Prashant? I'm audible, guys, for everyone.
Yeah, you
Yeah.
are audible.
Okay, Prashant, check your mic. You have maybe some issue at your end. So basically, HANA database is used for used to develop a real-time application. So data is available, uh, you know, whenever it enter into the table. So that data is available for reporting purpose. So basically, it is used for real-time reporting. SAP HANA is in main memory, uh, just a minute, just give me 2 minutes. Hey, sorry, yeah. So yeah, SAP HANA is in memory database, and it is column-oriented relational database management systems, and it is developed and marketed by the SAP organization. So its primary function as a database server is to store and retrieve the data as requested by any application. SAP HANA is in memory platform for doing a real-time analytics and for developing and deploying the real-time application. So basically, it is used for real-time application. For on-premise deployment, we have two options for the installation. When deployment means installation. So for on-premise, so HANA can be installed on on-premise, and also it is supported on the cloud as well. Okay. So for on-premise deployment, we have two options. The customer can have two options for the deployment. One is the we call appliance delivery models, and the second is the Tyler data center integration model. So we have appliance and the TDI. So Tyler we call in short TDI models. So two models is there, appliance and the TDI delivery models we have in HANA database. So it is customer choice which model the customer can choose. Appliance is basically costly, TDI is cheaper. So what is different between these two? So appliance basically SAP provide you the hardware. So if customer choose the appliance delivery models, then customer is then the SAP is responsible for managing the hardware. So SAP will provide you the hardware, and the SAP will install the OS. SAP means SAP hardware partner. Okay, so SAP hardware partner. So whoever the hardware partner with the SAP, they will provide you the hardware. They will provide you the OS. Okay, they will install the HANA database. So they will do everything. They will configure the internet networks, storage, everything in that appliance. So SAP is responsible for the appliance delivery models. So he do all the configuration. So SAP does all the configuration in the appliance delivery model, but it is costly. The second is the Tyler data center, that is the TDI module. So in that, customer has the choice, okay, to install HANA database on their infrastructure, on their hardware. So customer can choose their hardware, okay, and they can build the storage. Then they can install the OS, and then they can install the HANA database. Okay, so in the TDI, the customer is responsible for managing the hardware and the software and the OS. Okay, so when we have to choose appliance delivery models and TDI delivery models. So for example, if you have the critical application, okay, like ECC, BW system. So these two systems are basically very critical, and the database size is very huge. If database size is very huge, then you the, then you go with the appliance delivery models. TDI delivery models, you can go with the non-critical systems like non-production, okay, quality developments. This system you can install on the TDI delivery modules, but production you always choose for the appliance. Okay, okay, if it is on premise. Okay, so for example, in the cloud, for example, if you're installing the HANA database on Azure cloud, then there is a predefined VMs. So that VMs you have to use. That VMs is nothing but TDI VMs available on the Azure the clouds, okay, or AWS cloud. So whatever the cloud you're using, there we have the VMs, and that VMs is nothing but a TDI. Okay, clear this one? Any questions from here till now here in this slide?
The OS certificates and all, they are also included as a part of the TDI, or they are bought separately?
Everything is bought separately in the TDI.
Okay. And for appliance model, everything comes together, even the OS certificates and
Yes, everything. License, OS license, hardware license, then HANA database license, everything come with the appliance. But in the TDI, there is a separate license for the OS, then HANA database, everything.
Okay.
Any other question, guys? Fine. Okay. So let's move to the next slide. So why SAP HANA came into the market? So what is the reason? So we'll see that. Yeah, so let me finish first this slide. So if you see that the hardware and the software, so I said that HANA is the appliance, and appliance is nothing but the combination of hardware and the software. If you see the hardware side here, so there are a lot of innovation, done at the hardware side. Like if you see, few years back, like 10 years back, so that time in our laptop or desktop we had, in MB, the RAM size was in 256 512 MB size. Okay, but now if you see in our laptop or desktop, we can have up to 32 GB of RAM. Okay, so hardware side, we can see a lot of innovation is happening. So for the HANA database, we have to make sure that the CPU should be a multi-core. CPU should be a multi-core architectures, and the RAM 64 address space should be there. So all the hardware for the HANA database will come with the multi-core architecture and the 64-bit address for the RAM. Okay, so this is the minimum requirement for the hardware side. So if you have the multiple CPU, then you can have the massive parallel processing in the hard database. If you see in this example, 8 CPU into 10 cores per blade. So it is a multi-core. So that means that you have the 8 CPU, physical CPU, you have 8 physical CPU, and per CPU, per physical CPU, you will get the 10 cores. Per physical CPU, you will get 10 cores. Okay. So 8 physical CPU per physical CPU, you will get 10 cores. That means that you will be getting total 80 CPU. Total 80 logical CPU you will be getting in the HANA database. Okay, so HANA database will use this all 80 CPU to process the request. Okay, so multi-core is nothing but multiple the cores you have. So 8 CPU means 8 core. We have 8 core CPU. This is the 8 core CPU. We can say that 10 core. Sorry, it is a 10 core CPU. 10 core CPU per CPU. So 8 CPU into 10 cores. So if you divide, it will come to 80 GB. 80 logical CPU. So you will get 80 logical CPU in the hardware. At the OS level, you will see maximum 80 CPU. Coming to the software side, so in HANA database supports row and the columns for database tables. So it has row tables and the column store tables, and also HANA database supports compression. So whatever the data we store in the memory, that data is stored in the compressed format. Also HANA database provide you the partitioning. You can partition the tables, okay, in multiple partition. The partition is also supported in the HANA database. No aggregate tables. So the aggregate tables is not there in the HANA database. So this aggregate tables is basically talks about BW side. So in the BW system, there is a lot of aggregate tables if you are running BW on the Oracle side, BW on the Oracle database. Okay, so there is lot of aggregate tables are there, and which uh, and that increase their efforts. But in HANA database, if you're running BW on HANA, then you won't get the aggregate tables. And your no aggregate tables means that so whenever they do the modification at the object level, they that they can do very easily and very quickly. Okay, so they don't need to change everything. So their loads and all that. So they do the BW team, they do the lot of configuration when they change anything. So but in BW on HANA, if you're running, then you don't need to perform a lot of changes. So yeah, so it is because of the aggregate tables we don't have in the HANA database. Yeah, so BW team, they BW consultant, they have uh, information about the aggregate tables. Okay, how these aggregate tables, no aggregate tables kind of things work in the HANA database. They have much information on that. So as a basis, we can't get more details. So but as a feature, it doesn't have the aggregate tables. The last feature is the insert only on delta. So these are the main feature of the HANA database. So insert only on delta means column store tables. So HANA database supports a column store tables. So the column store tables are stored in compressed format. Even the row store tables are also stored in the memory in the compressed format. So the insert only on delta is basically applicable for the column store tables. So column store table is not optimized for the write operation. So the column store table is very optimized, good. It provides good optimization for the read operation. But for the write operation, column store is not optimized. To optimize the write operation, SAP uh, provided a delta merge process. So I'll explain this more in detail. Delta merge process in memory management. Okay, so whenever the delta merge process is run, so using the delta merge process, all the write operation in the column store are optimized. So whenever you perform delete, insert, update on the column store tables, then HANA database just perform a insert operation on the delta. So column store table has two part, main part and the delta part. So all the write, update, delete operation will go into the delta storage. Okay, and in that it will perform only insert. Okay, whatever you do, write, update, delete. Okay, so whatever you perform, like changing the data. So HANA database just do the insert on the delta. Okay, so only one part is there, insert only on delta. So this is applicable for the column store tables. So column store tables and the row store tables we'll see in this maybe today we'll complete that row store and the column store the tables. Okay, so these all are the main features. So so whenever the people are asked in the interview what is the the feature of the HANA database, what is the main feature of HANA database, so you can explain that row and the column store, it supports row store and the column store tables. It's provide you the compression, it support the partitioning. In HANA database no aggregate table is there, and it's provide you the insert only on delta, the mechanism for the column store tables. Any questions here, guys?
What is the minimum CPU requirement for this HANA database?
For installation, you have you should have 2 CPU, and 32 GB of RAM minimum for the installation, but you cannot store the data. So just you can install and you can practice, but you cannot install any application on that database. To install any application like SAP S4HANA, B4HANA, you require at least minimum 128 GB of RAM. Okay, and the CPU, it depends upon the how many person want, how many users will be accessing the database. So sizing we do. Okay, so we do the sizing for the CPU, we do the sizing for the RAM. This, okay, we'll see tomorrow the sizing part. So CPU part is dependent upon the number of users accessing the database. Any other question? Okay, let's move to the next topic. So if you see here, this is the past database. Okay, so traditional database like we have traditional database like we have the Oracle, Microsoft SQL, IBM DB2. So these are the traditional database and are the disk-based database. So data store on the disk. Okay, so whenever user requests the data, access the data, that data is loaded into the memory, and the memory is not enough to store all the data in the traditional database. And here we have the bottleneck. I have bottleneck between disk and the memory. Okay, so this is the bottleneck in the traditional database. But if you see the HANA database, so everything is there in the memory. So whatever the operation you perform, whatever the operation you perform, like insert, delete, calculations, whatever you do, that is done in the memory. Okay, so memory, it means in the memory the data is always there, and all the operation are performed in the memory. Okay, and we don't see the bottleneck between disk and the memory. Okay, so if you see here, we have the storage. Okay, here we have the memory, here we have the multi-core CPU. Okay, so the bottleneck is not there. All time my data is there in the memory. So whenever you start HANA database, the data is loaded from disk to the memory. Okay, whenever you stop HANA database, the data is copied from memory to a disk. So basically the disk is required for logging and backup purpose. Okay, in case of HANA database is crash. Okay, so how you will restore, because the memory is a temporary container. So when you stop HANA database, when you stop your operating systems, the data in the memory will be lost, because the memory is a temporary container. Okay, so here we have the storage, that is the disk, which is the permanent storage. Okay, where my all the data is stored. So whatever the data is there in the memory, the same kind of data you will see on the disk. Data is continuously synchronized between memory and the disk. So first access is the first primary storage for the HANA is the memory. Okay, so whatever we perform operations like update, change, delete, those perform in the memory. So those data is changed in the memory, and from the memory, from the data which is changed in the memory, that is copied to the disk at regular intervals. Okay, so I'll explain this later. So you will be having the one copy at the storage, okay, and one copy will at the memory. Okay, and memory is the temporary containers. Okay, so when you stop HANA database, the memory data in the memory will be unloaded, unloaded, and whenever you start the HANA database, the data is loaded into the memory from the disk. Any questions here? Hello, guys, you are getting right?
Yeah. It is clear.
Yes.
Yeah.
Yeah, any questions? Nothing, right? Yeah. So why SAP HANA database is introduced in the market? So what is the reason? Okay, we'll see that. So consider I have one table, okay, with this table contained the 2 trillion records and having 4 columns: customer, product, amount, and quantity. So in that, I have 2 trillions of records. So 2 trillions records means the table size will be in GB. Okay, 2 trillions record is very huge. Okay. Okay, so consider I am just want to execute a find out top 5 customers based on the amount on this particular tables where 2 trillions record is there. Okay, so consider this table structures and this 2 trillions records is exist in the traditional database like Microsoft SQL. Okay, in Microsoft SQL. Okay, I'm executing a command. I'm executing a SQL statement. Find out top 5 customer based on the amounts. Okay, so in Microsoft SQL, it will take more than 8 hours to answer these questions because it will scan all 2 trillion records. Okay, and then after a few hours, it will provide you the result. So it will take more than 8 hours to answer these questions. But if you consider same tables, same records, 2 trillion records, and in the HANA database, and if you're executing a find out top 5 customer, then in HANA database, you will the HANA database will answer these questions in less than 6 seconds. Okay, so HANA it will take less than 6 seconds to answer these questions. Okay, so what is the reason behind why HANA is taking less than less time as compared to the Microsoft SQL? So we'll see that. So what is the reason behind why HANA is taking less time? Because HANA is in memory database. It is columnar store database. It does massive parallel processing of the data. So these are the feature of HANA database. Okay, so these are the basic features. It's not a main feature. We can say that it is a basic features. Just give me 2 minutes. Sorry, my office, some activity is going on today, so I'm getting a call. Yeah. So this is the basic feature of the HANA database. So we'll see one by one. So we'll see what SAP HANA, what is in-memory database. We'll see column store database. Also, we'll see what is the parallel processing. So we'll see what is in-memory database. So consider I have the one servers. Okay, this is the box hardware or VM. Inside that I have the CPU. Okay, and then I have memory, and then I have disk. Okay, so these basics things we have in the HANA database. Consider this. So all the traditional database are the disk based database like MS SQL, Oracle, DB2 are the disk based database, and the HANA is the memory database, in memory database. Okay, so why SAP chosen the memory for HANA? Because why HANA why SAP chosen the memory for storing the data, because the memory is now, if you see that, is getting very cheaper. Okay, day by day is it is getting very cheaper, and it is faster than disk, and it is also faster for the data processing. So RAM is faster for data processing. Okay, and the memory, that is the RAM, is 100,000 times faster than a disk. Also, the data is there in the memory, and the memory is very closer to a CPU. That means that your data will be kept close to the CPU. Okay, with this feature, okay, you will get fast response of your data processing. Okay, so this benefit you are getting if you are keeping the data in the memory, and that is the reason SAP choose the memory for storing the data, and that's the reason they have introduced the HANA in memory database, which handle the massive amount of data, and will give you the quick results. Okay, so we'll see one example here. So we consider we saw that example, find out top 5 customers. So so if you see that how that SQL statement in the traditional database is executed, we'll see that. So whenever we execute a a statement in the traditional database, like in the Microsoft SQL, then the SQL query we execute, and then that SQL query is assigned to a CPU. So some CPU is assigned to the statement or SQL, and then the memory is assigned. Okay, and then after that it access the disk. It access the disk for processing the data. Okay, so 2 trillions of records. 2 trillions of records are there on a disk. Okay, just a minute. So when we execute any query in traditional database, I'm audible, right, guys?
Yes.
Yeah, sorry for today. Yeah. So today a lot of things are happening at my house. Okay. So when we execute any SQL statement in the traditional database, that SQL statement is assigned to CPU. Then it accesses the memory, and then it accesses the disk. So on the disk we have the 2 trillions of the records. That 2 trillions of the records, we have executed a query, find out top 5 customers. So that 2 trillions of the records will not be loaded into the memory. So what happened in traditional database? The 2 trillions record is loaded into the memory, in partially. Okay, so some records will load into the memory, then statement will look for the data, and then those the loaded data will be unloaded, and then the next part of the data from the disk will be loaded into the memory. So here lot of the loading and unloading is will be happening. Okay, okay, because why? Because the data size for the table size is 2 trillions records. Okay, and 2 trillions records will memory will not able to load at a time, so it will load and unload the 2 trillions records, and then after loading, after scanning all the records of that particular tables, it gives the result to the CPU, and then from the CPU the result is sent to the users. Okay, so if you see that here we are wasting a lot of time. So here in the traditional database, like in Microsoft SQL or DB2 Oracles, 90% of time we are wasting just loading and unloading the data into the memory. Okay, okay, and 10% is required for processing the user's request. Okay, so if you see in previous example, the SQL is taking more than 8 hours. So why it is taking 8 hours? Because here it will perform a loading and unloading. To load 2 trillions of records, here lot of the time will require. maybe 10 hours, 18 hours, something kind of. Okay, more than that. Okay, but in the HANA database, if you execute the same query, find out top 5 customers, then the CPU is allocated to the SQL statements, and then that statement will access the memory, look for the tables. That tables there in the memory, because HANA is in memory database. It will look for the tables records. It will scan, and then it will give the results to CPU, and then from CPU it send the result to the users. Okay, so if you see that here, the statement, the operation or request is not accessing the disk. Okay, it is not going to disk because my data is always there in the memory. So it performs some calculations, okay, and then it gives the result to the CPU. So here if you see that 90% of time we are saving in HANA database, but here in traditional, no, 90% of time just here we are just wasting, loading and unloading the data. Okay, whereas in HANA we are saving the 90% of time. Okay, only 10% is time is required for processing the user's request. So we are getting the benefits here. Okay, also we are getting the benefits of RAM. Okay, which is faster than the disk. Okay, so HANA, that's the reason it is taking a less than a 6 seconds. Okay, if you see here, 90% times we are just wasting the loading the data from disk to a RAM in traditional database, and 10% we require for processing. Okay, and that's the reason HANA is much faster than any disk-based database. Yeah, clear this one? Any questions here?
No.
One question. You said that once we stop the database, then the whatever data is there in the in-memory storage, that is again unloaded. And when we start the database, then it will be getting loaded. So is
Correct.
it also true that for the first few transactions, then it will be slower, or because it is loading from the disk to the memory, or
Correct.
that is
So,
also optimal?
correct. So initially it will be slow. Once all the data is loaded into the memory, then you will get the good performance.
So it does it behave like a cache, like?
No, it is not caching. So in the memory management, I will explain more in detail. Okay, so how the data is loaded into the memory. So it is not kind of caching. Okay, so yeah, so we have the row store tables, column store tables. So the row store tables, whenever we start the HANA database, the row store table is by default loaded into the memory, and for the column store tables, the column store tables are loaded in on demand. So whenever the user access the column store tables, that tables is loaded into the memory only. Okay, so it's all depends upon the access, so on demand. So if there is a demand for the column store tables, then those tables will be loaded into memory like this. So when we say that HANA is in memory database, that is partially correct, okay, but not fully, because the it is correct for the row store tables. So all the row store tables will be there in the memory whenever you start the HANA database. But for the column store tables, that the column store tables will be loaded on demand. So whenever there is a request for access, then only that table is loaded from disk to the memory. So we'll cover that more in details in memory management. Yeah.
Also, column store is, you said, write optimized, right? So I mean, the row stores are read optimized.
No. The row store is the write optimized, and the column store is the read optimized.
Okay.
We'll see that after this. We have the column store and the row store.
Okay.
Guys, any questions here? Prashant? Everyone is there, right?
No, sir.
No
All good, right,
question.
guys?
Yes.
Yeah. You can ask any questions, guys. Okay, so what advantages we are getting in memory database? In memory means all data is stored in the memory, that is the RAM, that is the temporary container, and there is no time waste in loading the data from hard disk to a RAM. So this time we can save. Everything is in memory all times, which gives the CPU quick access for data processing. Okay, so these are the benefits we are getting in memory database. The column store tables. So what is the column store tables? Okay, so consider I have one tables in that I have columns country, product, sales, and I have the total 4 records. That is the row 1, row 2, row 3, row 4. In that I have the India, Germany, and the US as a country, at the product, chocolate, ice cream, noodles, and the sales. Okay, so before understand the column store database, we'll understand the row store database. So what is the row store database? 2 minutes.
Hello.
Actually, my internet, I have 2 internet. So one is not working. That person is saying yes. So he's looking for that issues. I'm audible. Hey, what is any issue, Das?
Yeah, now it.
Yes, it is audible.
Yeah. No, I was away for 2 minutes because that guy was calling me. The internet, some issue is there in internet. So I have 2 broadband. So one broadband is not working. Yeah. Okay. So fine. So here, if you see that before to understand the column store, we need to understand the row store. What is the row store? So in the row store, if you see that how this data is stored in the row store tables. Okay, how this data data is stored in the row store database. So it is stored in the sequence of the row, like row 1, row 2, row 3, row 4. Okay, like this, row 1, row 2, row 3, row 4. Okay, so this is the it stores the records in the sequence of row. Okay, so this is the logical storing of the records in the row store tables. Okay, so in the database. So all the traditional database, if you see that IBM DB2, SQL, and Oracle are the row store database. It only supports a row store database. Okay, so consider if you want to perform a read operation or write operation. So how many read and write operation you require? So which one is the expensive and which one is the cheaper? We'll see that one. Okay. So for the row store, if you want to perform a read operation, for example, if you want to count how many times as a country India is appearing in this particular table. So by looking the records, we can say that the count for country India is 2. Okay, that is we are reading the tables. Just we are just giving the select statements. Okay, so select statement is nothing but the read operation. So how many read operations you do? So number of records means number of read operations. So it will scan entire records to read all the records and will provide you the results. Okay, so number of reads it's required. So in the row store, the read operation is very expensive. The read operation is very expensive. Whereas if you want to perform a write operation in the row store tables, then at the end you can add the here in the row store here you can add the row 5. So row 5, like whatever the records you have, you perform only one write operation to insert the row 5 in the row store table. So writing in the row store is cheaper, okay, which required a less operations, less write operation. The reading is expensive, okay, in the row store. The reading is expensive, writing is cheaper, that is faster. Reading is slow. When I say expensive, means it is slow. When I say cheaper, it is faster. So writing in the row store is faster, reading in the row store is slow. Okay, so all the traditional database are the row store table, row store database. Now we'll understand the column store database. The column store database, in that column store database, how this table is stored, it is stored in sequence of column, okay, like country, product, and sales. Okay, so if you want to perform the read operation, okay, so we have in the statement we give the the columns name, like country equal to India, select star, the country equal to India. Okay, so on a column store, it directly read that particular column. So whatever the columns you specify in the statement, it read that columns directly. Okay, so here if you see that country columns is there, it read and it scan and it will give you the results. So here you require only one read operation in column store. So reading in the column store is cheaper, means faster. Okay, if you want to perform a write operation, like if you want to write a row 5, then you need to write a records in the country columns, then product columns, then sales columns. Okay, so writing in the column store is expensive, means slow. Okay, so in the column store, reading is faster, writing is slow, whereas in the row store, reading is slow and the writing is the faster. Okay, so HANA database supports both row store and the column store database. So only HANA supports row store and the column store tables in the HANA database. Okay, but why we call HANA is a column store database? What is the reason why we call HANA is the column store database? Because whenever the developers they create a tables, they have to specify which table they want to create, as a row store or the column store. Okay, so if they specify the table created as a row store, then table will create as a row store. If they doesn't provide anything in the statement, then that tables by default created as a column store. If developers doesn't provide any, if they forget to provide the table types, row store or column store, then by default that table is created as a column. That's the reason we call HANA is the column store database. Yeah, clear this one?
Please repeat again, like why it is column store, like why you call
Because
it.
yeah, so why we call HANA is the column store? Because when the developers create a tables, when the developers create a tables, they specify the table type, row or column. They have to specify. If they forget to specify the table types, then that table is created as a column tables. Okay, that's the reason we call HANA is the column store database.
So we generally choose the thing based on read or write operation. Like
Yeah,
if,
correct.
okay.
Yeah, so based on the business requirement, if the developers if the requirement is for performing a read operation, then they create a column store tables. And if there is a requirement to perform a write operation, okay, then the table will be created as a the row store. Okay, so transaction, if there is a transaction happening on that particular table, then the table will be created as a row store. If that table they want to create is used for reading, that is for reporting purpose, then it will be a column store. So they have to decide based on their business requirement. Yeah, go ahead. Somebody was asking questions. Hello?
No, it's clear.
Any other question, guys?
I have a question. So the SAP standard tables are rows to.
No, not like this. So yeah, so for example, so if you are installing the S4HANA system or APO systems, okay, so these all systems are the transactional systems. Okay, so you will see most of the tables are the row store tables. Okay, some table will be there column store for the finance tables. Okay, finance table will be having most of the column store, but in the transactional application like S4 HANA and the APO systems, okay, SCM that we call SCM, CRM, that are the transactional application. In that you will see that 90% of the tables are the row store tables, because there we performing the write operations. Okay, BW systems like BW on HANA, before HANA, okay, those systems are used for analytical purpose, like reporting purpose. So in that you will see a lot of tables are the column store tables. So it is basically depends upon your application types, whether it is OLTP or OLAP, that decide. So during the installation, it's create row store and the column store tables based on the your application type, whether it is OLTP or OLAP. Clear?
Yeah. Is there a way to check also that this table is row store or this is column store? Will it show somewhere clearly?
Yes, yes. So when you open the tables, so if you go in the HANA Studio, in the catalogs schema, and when you open the tables, and if you see the table property, it will show you whether this table is column store or the row store.
Okay. Okay.
I'll show you that once we install the HANA systems. I'll show you that how to check whether it is column store or the row store. Yeah.
Okay. Thank you.
So difference between row store and the column store. The memory uses is higher in the row store, and in the column store it is lower, because for the column store tables, the compression ratio we are getting very good, whereas the row store the compression ratio is very high. Okay, so means high means the ratio we are not getting good in the row store, but the ratio in the column store for the compression we have very good, and that's the reason the memory uses for the column store is lower. Transaction, that is the writing in the row store, is faster, whereas in the column store is slow. Analytics means reading, it is slow in the row store, faster in the column store. We'll see that massive parallel processing. So what is the massive parallel processing? So it basically depends upon the CPU. Okay, so if you have the multi-core CPU in the HANA database, then you can have the parallel processing. So let's understand, okay, what is the parallel processing. So consider I have one building. Okay, so inside that building I have the 6th floor, and I want to paint this all entire sixth floor. So I hire one person, okay, and that person told me that it takes 1 day for one floor to paint, so 6 days it will take to paint entire building. Okay, so 6 days it will paint my entire building. But what if I hire 6 person? Okay, then this 6 person will paint my entire building in 1 day. Okay, so if you see that this person is nothing but a CPU, this person is nothing but a CPU, okay, and this is nothing but the process. Okay, processing, that is the request, we can say that. So request we can say that, and this is the CPU. So the number of CPU, you will get number of requests executed in parallel. So all the request is executed in the parallel in parallel. So this is called a parallel processing. If you have the n number of CPU, then you can have the n number of parallel processing in the HANA database. So HANA database basically for the CPU requirement should be a multi-core. If you have 2 or 3 CPU, or very less CPU like 10 or less than 10, then you won't having the good performance. So you won't get the good performance for the HANA operations. Okay. So yeah, so the CPU size, number of CPUs depend upon the sizing of the user. So how many users going to access HANA database at a time. So concurrently, how much user will be how many user will be accessing the CPU, or based on that the number of CPU will be decided. Okay. So yeah, so multiple CPU you will get multiple the parallel processing. Yeah, so this is we call parallel processing. Any questions here? Guys, any question? Yeah.
No.
Okay. So it's just simple. Just wanted to understanding you that what is the parallel processing. So this is the CPU, this is the request. So in HANA we have n number of CPU. If you see, if you have the HANA systems, if you go at the OS level, and if you see the ls CPU command, then you will see the number of CPU from 0 to 24, something like 0 to 79. If you have the 80 CPU, then it will show you 0 to 79, something like that. What I'll do, I'll stop here today because I have some other work. So tomorrow I'll continue the architecture and the sizing. Okay, because if I start this one, then again somebody will disturb me. So yeah, so it will be a difficult, because this is the critical one. We need to understand the architectures, HANA database architectures. Yeah. From next week, uh, from the Saturday and Sunday, I'll schedule this class in morning batch. Okay, so you guys are all available in the morning, right? 10 o'clock, 10 to 12 morning.
Yes, yeah.
Okay, so next week everyone is available.
Yes.
10. Rakesh, Prashant.
Hello. Actually, it will be better if you schedule it in the afternoon. Is it
Mm,
possible?
afternoon, yeah, fine, but morning, are you not available in the morning?
No, actually, I have some urgent work. That is why I'm.
Only all the weekends, or only these weekends only?
No, for the next weekend only.
So next weekend only on Saturday or Sunday?
Saturday and Sunday both.
Okay. Okay, fine. So this Saturday, Sunday we can have 3, and then from next on 20 we can have the Monday morning batch from 22nd. That is fine for everyone. For 15 and 17, 15 and 16, we'll have afternoon batch, 15 and 16, and from 22nd we'll be having the morning batch. Okay.
Okay.
Jada, are you okay with this?
Yeah, only the next weekend we are having it
Yeah.
same time, right?
Yeah, correct. So we already discussed on that.
Yeah, sure.
Fine. So tomorrow we'll meet same time, 3 p.m. Okay, and we'll see the architecture and the sizing. That is the very important. So I don't want to start today because a lot of disturbance is there at my house today. Yeah.
Also, you'll be sharing the record on daily basis, or is it like
Daily basis. Daily basis.
okay? Fine.
on your Gmail. I'll share via the Google Drive, so you can download it. Okay.
Thank
Thank
you.
you all.
Thank
Thanks
you.
all.
Bye.
Thanks. Bye.